Our technical booklet will be discussing the use of unmanned aerial vehicles for harmful algal bloom management in freshwater and marine commercial fisheries. Algae are primary producers, forming the base of the food web, making them vital for aquatic ecosystems. However, rapid proliferation of both toxic and non-toxic algae species can have detrimental effects on the aquaculture industry. Non-toxic algal blooms cause issues to aquaculture production as they may clog fish gills, deplete dissolved oxygen levels, and block sunlight. Proliferation of toxic algae species are referred to as harmful algal blooms, or HABs. HABs are a problem faced globally by aquaculture industries, causing economic losses due to fish mortalities, decreased feeding and growth rates, food safety issues, and negative impacts on quality of production. Current methods for detecting and monitoring algal blooms include dipstick test kits, satellites, and aircraft remote sensing. Dipstick tests are limited through infrequent sampling at fixed monitoring stations, which cannot provide adequate information due to the heterogeneous nature of algal blooms. Multispectral and hyperspectral satellite analysts are commonly used to identify algal blooms. Whilst these technologies offer high temporal and spatial resolution, they can't be modified to perform specific tasks or capture specific properties. Another disadvantage of satellites is that cloud cover and ice formation limits the visibility of the images. Aircraft remote sensing has several advantages compared to satellite use, including finer spatial resolution and greater flexibility over time and location. However, routine and real-time monitoring has still not been achieved by aircraft remote sensing due to the significant expenses of flights, as well as the geographical scope limitations of the sensor. Both aircraft sensors and satellite imagery still require physical water samplings to validate the results. Algal blooms have impacted aquaculture industries all around the world. The economic and health concerns associated with these blooms highlight the importance for new management strategies and the need for reliable monitoring technologies. Our technical booklet will review current UAVs being used on the market to monitor harmful algal blooms. It's aimed at aquaculture farmers, particularly salmon and shellfish farmers, and will provide a comparative analysis allowing them to determine which product is best suited to their enterprise. There are two main platforms used in UAV-based algal bloom research: fixed-wing and rotorcraft drones. Majority of fixed-wing vehicles being used are EB hardwares, and majority of the multi-rotor use DJI products. We will be comparing the EB Classic and the DJI Inspire 1, as these have been effective in previous monitoring studies and are still available on the market for purchase. Previous UAV-based algal bloom research has shown that there are clear benefits and limitations between these two drone types. As highlighted on the screen, the EB Classic has a longer battery life and can be used to cover greater distances in a flight. However, its use is restricted by suitable areas for takeoff and landing. Whilst the DJI Inspire 1 may not be able to cover as large distance or have as great as potential to carry multiple sensors, it has been previously used to successfully collect water samples and allows for small or microscopic algae observation. The effectiveness of the flight is limited by environmental conditions, with high winds and propeller movements blurring the images. There are two main sensors being utilised to monitor algal blooms: multispectral RGB and infrared cameras, and hyperspectral cameras. Hyperspectral cameras allow greater precision in determining species or genus composition of algal blooms, but they come at a greater cost and have a heavier payload compared to the multispectral cameras. UAVs are effective tools to monitor algal blooms, and by selecting the appropriate hardware and sensors could help to reduce the economic losses faced by aquaculture industries. UAVs allow for frequent routine monitoring at a relatively low cost, and by integrating sampling methodologies with the UAV platform will help to reduce time and costs associated with manual water samples. This technology will allow industries to detect algae proliferation at a microscopic level, allowing them to make the correct management decisions and minimize their losses.